You need to write them, or else you're going to get points marked off. Where are we? Number 62. The question or the comment that I just heard. Everybody listening? The question or the comment that I heard is that some people are not putting in the angle statement, like sine of x or sine of theta or sine of y or sine of beta or whatever the case might be. As we move further into chapter 3, they're not always going to be the same. You're going to have alphas, you're going to have betas, you're going to have negative alphas, negative betas, thetas, that kind of stuff. So there has to be an angle argument in there so you know where the angle is going. It'd be kind of like writing f of x notation without the f of x, because trig notation is f of x notation. We're just using 3 letters to name the function instead of 1 letter. Call it function f or function g. We're calling it function sine or function cosine. So you've got to have a input argument or an input statement. And those aren't always going to be the same for an entire problem. You're going to have different alphas and betas and all that kind of stuff within the same problem. So you need to make sure that you are taking that extra little step and actually writing it out correctly. So 62 is a question unless
63.
63 instead. So 63 out of section 3.1. So 63, they start you out with 1 over sine cubed. Minus cotangent squared over sine of x. So we're just trying to simplify here. So we don't have an equal sign. We don't have anything to try to match it to. So we just need to kind of go through some of the basic stuff and see if we can simplify it down. What I see when I look at this is I see a fraction take away another fraction. So what do you need to subtract fractions? Common denominator. So let's maybe lay it out as some fraction take away some fraction. So what's the common denominator going to be? You're going to have to represent factors of sine. You have 3 factors of sine. And then this one's a factor of sine. So you're going to need a denominator of sine cubed to represent all those factors of sine. What did you do to this one to create that one? Times it by 1 basically, because it didn't change. What did we do to this denominator? We factored in a sine squared, so we got to factor a sine squared into the top. And now we could go ahead and put those 2 fractions together all over a common denominator. So it's going to be 1 minus cotangent squared, sine squared, all over a common denominator sine cubed. And what could we do from there? One of the other techniques we've been studying is switch things to sines and cosines, right? So what is cotangent? Cotangent is cosine over sine. So cotangent squared would be cosine squared over sine squared. And then we have our sine squared over 1, and that's still all over sine cubed. And then what do you see from there? The sine squareds are going to cancel, right? So that's going to get 1 minus cosine squared all over sine cubed. And 1 minus cosine squared, that has some of the components of the Pythagorean identity. Is it going to be negative or positive? So if we brought the cosine over to the other side with the 1, so we're going to be left with positive sine squared on the left, and then 1 minus cosine squared on the right. So this is just going to be a sine squared over a sine cubed. And you get 2 factors of sine up top and 3 factors of sine down bottom. So you're left with 1 over sine. And 1 over sine is the same thing as cosecant. So that should be simplified down. So kind of 2 major skills in there. the start, which was there's a fraction trying to be subtracted with another fraction, and then switching to sines and cosines, which is one of our primary maneuvers for trying to simplify things.